Welcome to the third part of Chapter 4, Requirements Engineering. In this part, we will cover requirement specifications, requirements and design, ways of requirement specification writing, guidelines for writing requirements, form-based specifications, tabular specifications. So these topics will be the headlines of what we are going to discuss during or throughout the slides of this part. Initially, we need to make clear a few things. The first one is the requirement specification itself as a process. What is it? So the process of actually requirement specification, or the idea or the concept, is writing down the system and user requirements in a document. That means we create a formal document, and this document is used in many different ways. One of them is actually for contract agreement. That means we need to see what is the user requirement, and you remember from previous parts we explained about the user requirements are usually tend to be non-technical, less technical than and detailed, less detailed than system requirements. So they provide the idea of the system, actually the external view of the system to the user or the customer, and what the system is supposed to provide to them. So we need to write it down in a document, and this document will be sort of a discussion and also a type of an agreement part with the customer or the client. All right. So as I said earlier, for user requirements, usually we tend to be non-technical. We avoid abbreviations and things that non-technical people or customers usually do not know. Also, we try to explain the external behavior of the software itself, the functional requirements. Also, we present them in a readable and understandable way that non-technical people usually can grasp and understand. For system requirements, the idea is a bit different. We detail the requirements, and we explain things in, you can say, more deeper way of explanation. We present things that usually are not included in user requirements. We may provide also constraints on the system's operational process. That means not only the functional requirements, also we would be describing the non-functional requirements as well. So you may think about that particular difference between system requirements and user requirements. Well, after presenting these two and providing them in a document, then we have an official document to be attached to the agreement details between the developing company of the software and the client or the customer of the software. All right, let's move forward. Requirements and design. So we mentioned about requirements here and what we are supposed actually to provide in the requirements document as user requirements and system requirements. Do we need to provide things about the design and the implementation? Actually, it's not. Usually we shouldn't. So the design and implementation are not required to be presented in the requirements document or the specification document. Why? For one simple reason. They are not a part of what we call requirement specification. Why? They do not represent actually what the user and the system are requesting from the software or the implementation of the software itself. However, we cannot usually totally separate in practice, or practically we cannot separate the design from the requirements or the presentation of the requirements. Why? We have different reasons. The first one is sometimes while we are explaining the functional requirement of a system, we need to present it in a structural way. You can say an architectural building. So you can see the building blocks of the system. That's one of the reasons. The other reason is sometimes we need to see how the system is fitting in the surrounding or the other systems around it. So we need to present that in a design way. That means we need to put some block diagrams or things that we fit them together. One more thing. Sometimes we need to see how non-functional requirements are presented. So we need to know exactly what type of non-functional requirement is imposed on the system before putting the system in operation. What does it mean? As we mentioned in previous sessions, that we have usually a domain requirement, and this domain requirement usually dictates a regulator or someone who comes from outside inspects things related to non-functional requirement like safety, security, maybe. So these will be checked by an external supervisor or regulator that dictates that this kind of safety policy is supposed to be there in the software. Well, how can we present this one easily with just a written form of document without presenting any design or you can say diagram? Usually we have such a simple design along with the requirements specification and in the documentation. This is usually a way that most of designer or developers of software applications use. All right. So what kind of ways of writing for the system requirements do we have? We have different ways for writing the requirements. We have actually a number of ways that are still in use and actively actually being used, a number of, and others are casually used or based on some occasions or maybe based on request. The first and you can say the most initiative, or actually the oldest version of the way of writing requirements, is actually natural language. Natural language is exactly the language that we speak and write with it. So you imagine like an English written text presenting the specifications, and it should be readable, that we can read and understand and make a sense out of the sentences that are provided. Structural natural language. We use natural language in this case, but we put certain structure or standards, so we limit the use of free style of writing. So we need to go to a bit of standardization in this case. Design description language. In this case, we use something like programming language. Actually, we put things in terms of a programming style, where we use abstract in actually more details for presenting the specifications in details. Graphical notations. This one I will have to provide another or separate video discussing the graphical notations. Graphical notations actually used for, usually in most of cases, the idea of design more than just the explanation of basic sentences about the requirements. Usually we impose graphical notations for designing of things. We use the common unified modeling language for such a case. We have like case diagram, sequence diagram. These are used for presenting functional requirements. We have also for non-functional requirements some considerations for non-functional requirements. I'll make another video separately for the graphical notations and discussing UML. We will use a special software for it. Mathematical specification. This is extremely specific, and it is based on some mathematical representation. If you remember the finite state machines we explained last semester in discrete mathematics, these are widely used also for some sort of design or explanation of the system or the software system. They are used as supplementary of the descriptive text, so that we can just reduce the ambiguity available with the requirements in hand. This is not widely used, and it may create a confusion with non-technical people. They may not understand the finite state machine presented unless you explain it to them, and you don't need to have that headache explaining very deep technical process to non-technical people. Most of the time that takes time and effort. So no need to go for such a thing unless there is a need. Maybe if you're going to design a software for some technical people, maybe you go for that mathematical specification, or if it is requested by the client, that could be a good idea to do. Natural language. So this is the first, and I said this is the most initiative of way, or the first, you can say, type of language that that was and still in use for writing the requirements. We use natural language, the language that we speak and write with, and we may use some tables or some diagrams to support the sentences that we write. So why do we need to use such a language, or what kind of reason forces us or encourages us to use such a representation for the requirements document, or the specification document in this case? Because it is expressive. That means we can express what we are looking for from the system as users request, and also as the system dictates. Also, it is intuitive. People can understand it, they can make sense of it. And universal, that means worldwide, natural language is accepted. Well, the language itself is not necessarily we are speaking about one specific language in particular, no. But the language, the natural language that people use, we may have different languages. However, in technical knowledge, you can use formal natural language, so that people can properly understand it and make sense of it. All right, so as I said, it is expressive, intuitive, and universal, and it should be written in a way that non-technical people, that means users or customers, can understand. So the way that we provide our descriptive sentences can be easily understood by non-technical people. I can understand that this point particularly is not easy to be understood by software engineers. Why? Because when we speak about such a thing, usually those who are in the field, in this technical field, they cannot understand what we are referring to. However, when you speak or when you present your ideas to those who are coming from non-technical background, they cannot exactly understand, especially if you use abbreviations or jargons about the field itself. And that's why you get stuck somewhere. You may use some abbreviation about some software or a tool or something. They get stuck and they tell you, what do you mean? So in that case, you shouldn't use these things, and you should make your sentences clear enough so that non-technical people would understand and make sense of. Guidelines for writing requirements. So we said this is the natural language specification, but as I said earlier, we cannot just give a freestyle, write whatever you like. No, there are these points, these 5 main points that we should include in our or consider in our requirements document before writing it or while writing it. So initially we have to create our own form. So we don't just have a freestyle every time you just write whatever you like the way you like it. No, you should create your own standard form, and then you can use it every time when you have a request for a development or an agreement for a development. And then you should use a consistent way of structure of sentencing. What does it mean? You can use shall, for example, for mandatory things like must things. So any must requirements, you can use shall, and for maybe recommended or desirable requirements, you can use should. So if you are going to use shall and should, you should use them, both of them, in the consistent way. You can specifically use shall for mandatory and should for desirable or recommended. Also, we can use highlighting, text highlighting, bold or italic for key parts of the text or the requirements, or sometimes explanatory statements about requirements and so on. As I said earlier, we should use non-technical way of description, so we shouldn't use jargons about the field, terminologies of the field, and things related to our own field, like abbreviations, things that usually non-technical people will not be able, or those who are not familiar with the field will not be able to understand. We need to include an adequate explanation about the requirement and why it is necessary. This is what we refer to by rationale. So the rationale of the requirement should be provided. You can use an extra statement to present it so that you clarify why this requirement is presented, for what reason. We may get stuck with the following problems in natural language. The first one is lack of clarity. Well, it is not that much easy to explain and clarify everything with a written text. So, well, if you are supposed to have everything explained in details, then your document will be extremely hard to understand. It will be too much detailed, and those who will read it will just get lost within the text and will not understand what you are trying to say. Confusion. Sometimes when we describe the requirements or when we provide the specifications in a document where we present sentences about the requirement specifications or the description of user and system requirements, we get functional and non-functional requirements mixed up, and this is usual. We explained about usually we have a very fine line between functional and non-functional requirements, and if you are just explaining those by words, not by diagrams and further explanation by certain mechanism like UML or whatsoever related to design, it will be a bit tough to understand. Things will get a bit mixed up. Sometimes we have one sort of scenario when we express more than one requirement or actually multiple requirements altogether. This scenario is actually widely available in software industry, and the problem becomes extremely hard to distinguish when we have very similar requirements addressing different problems or different types of functionalities or modules that produce different functionalities, but they are a bit related to one another. This is also one of the problems that we usually have while dealing with natural language. This is, before I forget, this is referred in English as a terminology and amalgamation. It's like when you mix up things all together because of maybe their relatively related functionality, or maybe they seem to be serving the same point. Okay, and look at this example from the insulin pump software system. Imagine that we are creating an insulin pump software system for producing the dose, automatically producing the required dose of insulin as a medication of, you know, those who require the insulin because of the sugar in their blood, for monitoring the sugar in the blood. So let's just go ahead and read and see how things are done. The system shall, so this is mandatory, it's a must, shall measure the blood sugar and deliver insulin. Well, so that means it's a must for the system to measure the blood sugar, and it's a must to deliver the insulin or the dose of the insulin if required every 10 minutes. So the measurement is done every 10 minutes, and that's how the system monitors the sugar in the blood or the sugar level in the blood. Now look at this italic. So this is an italic explanation about the statement here. Changes in blood sugar are relatively slow, so more frequent measurement is unnecessary. Well, that is why you may ask, or maybe it's already a question in your mind, that why in 10 minutes? So this is exactly explains it. Changes in blood sugar are relatively slow, so more frequent measurements is unnecessary. We don't have to measure more frequently than 10 minutes. So 10 minutes is an adequate period to have the measurements within or after 10 minutes each time. Okay, less frequent measurement could lead to unnecessary high sugar levels. That means if you go for things like higher than 10 minutes, 15, maybe 20, maybe half an hour or 30 minutes, we may miss the necessary or maintaining the necessary sugar levels in the blood. And that's why this is the explanation of, or the rationale of the requirement here. Okay. And is it a system, by the way, let me ask this question, I'm just, as I said, let me ask it, this part, is it a system requirement or a user requirement? Think about it, just think about it. Is it system requirement or user requirement? Okay, the system shall run a self-test routine every minute with the conditions to be tested and the associated actions defined in table 1, okay? So this is also mandatory, it's a must. So the system must run a self-test routine every time. So what is the reason? Why do we need the system to run a self-test? What is the point here? A self-test routine can discover hardware and software problems and alert the user to the fact that normal operation may be impossible. Well, this is the idea. So we run this self-test every minute to make sure that our both software and hardware are fine running with a normal operational process. Otherwise, we may have a failure in the system, either software or hardware, and we are not quite sure about it. So self-test will give us an alert, okay, about whether the condition of the system or the situation of the system. Structured specifications. Now, earlier we said about the natural language. We have the free style of writing. However, we use highlighting and we avoid jargons and so on. We discussed these points. Let's go to a more standardized way. This way is where we use a structured specification. So we abandon a little bit of the freedom of the style that we use in natural language. We limit it to a more standardized way, and where we provide, you can say, pre-decided fields. So these fields, we explain about them with specific titles and subtitles and so on. So this will make it a bit more clear and will make us a bit more restricted. The idea of such a scenario may work for, you can say, small-scale systems and systems with non-business oriented scenarios or applications. For such like, business-oriented systems, usually we don't go for such a thing. We have other ways to write the requirements, usually. Okay. Form-based specifications. Now, when we explain about the idea of structured specification, we said we go for standardized way where we have titles and subtitles or subheadings are preset. So in this case, what we are considering is actually form-based specification, or providing the specifications based on a form or a preset form. So in this case, we can consider the followings in the idea or within the form that we are discussing or we are addressing. Definition of the function or the entity, what kind of a function we are addressing, or what is the function of the whole software at the beginning. It could be a title, then we have any entity or function with subheading. Then we have description of the inputs and where they come from. So what kind of inputs do we have to the system, and these inputs, where they are coming from, what is their source? You may think about a source of an input as a sound or an image or a video, a wave. Anything comes to your mind. It could be a possible input. It could be a mathematical calculation. It could be a number, random number. So all these, where are they coming from? Is it randomly generated? Is it coming from space? Is it coming from air? Is it coming from where exactly? So we need to know the source of the input. Maybe the memory, maybe already counted and stored in our memory or the computer's memory. Description of the outputs and where they go to. So if we are producing outputs based on some inputs and processing or calculations, then we need to have some outputs, and these outputs will be provided or will be presented to some functionality, maybe display, maybe will be provided to another processing stage or mathematical equation to be discussed or to be addressed. We need to know also information about the information needed. So if we are thinking about a computational process, just a simple mathematical equation, we need to know the details of the information that we are going to achieve or get, okay? And the information about what we are processing, and also information about what we are about to get. So all these things must be explained in details. Description of the action to be taken. Well, we said about the inputs, we said about the outputs. How about the processing or the actions that we take? So we need some description about those also. Pre and post conditions, if appropriate. Do we have a precondition or post condition? If we have preconditions, then we need to put the border or the baseline where they will be true. And also the post conditions, we need to put the baseline where they will be true. So pre and post conditions. The side effects, if any. So while using the system, or by using the system, do we expect to have any side effect? Is there any? So we need to take care of, and we need to tackle it. And look at the structured specification of a requirement. Usually we highlight, and you see the freestyle is gone. We don't have freestyle like this. No. You may tell me it has numbers. Yes, it may. Well, numbering has nothing to do with the formatting process here we have. Now look, we have a title, or maybe heading, insulin pump / control software / the version of it, for example, abbreviation for the version of that we have of the software now. Now, first, function. What kind of function the software is doing or is providing? Compute insulin dose, save sugar level. So we compute the insulin dose to maintain a safe level of sugar in the blood. Description. So for the description of this functionality or the functionality of the software, computes the dose of insulin to be delivered when current measured sugar level is in the safe zone between 3 and 7 units. Well, it may not be clear enough now. Just pass it. This is just a description. Pass it now. Inputs. Current sugar reading. So we read the sugar from the blood by certain sensor. And the previous two readings, so we have previous two readings, R0 and R1. So we have two readings stored in the memory and one current reading that at the moment is read. Okay. Source, from where we get these readings. Current sugar reading comes from a sensor. The previous ones come from memory. Why? Because we need to read them and store them. Sensor will not keep the current reading. We'll just get it and provide it. So outputs. We compute the dose, and this dose of insulin will be delivered. So it will give an instruction to some reservoir to pass the insulin to the patient. How about the destination main control loop? This is a medical, like you can say, procedure where we provide an instruction to somewhere for providing drops of insulin or medication to the blood circulation of the patient. Okay, the action. Now this is a description of the whole scenario. The comp dose or the computed dose is 0 if the sugar level is stable or falling. If the level is increasing but the rate of increase is decreasing. Well, you may tell me it's really hard for me to understand. Hold your patience. You don't have to worry now. Okay, I'll explain it in a while. Just keep it. I have a point to hold the explanation of this one. If the level is increasing and the rate of increase is increasing, then comp dose is computed by dividing the difference between current sugar level and the previous level by 4 and rounding the result. If the result is rounded to 0, then comp dose is set to the minimum dose that can be delivered. Okay, I know this one is not clear up until now. Hold your patience, I'll explain it, and I have a point to delay its explanation. Requirements. What kind of requirements do we have? 2 previous readings. Without these 2 previous readings, we cannot compute the dose We cannot monitor the rate of the change. Okay. And preconditions, what kind of preconditions do we need to have? We need to check the reservoir of the insulin, whether we have at least a maximum allowed dose or not. If we don't have the maximum allowed dose, let's say our calculation provides that we need to inject, or we need to provide, or we need to supply insulin dose to the maximum, yet in the reservoir is not available. Then this is a precondition which should be held true before or to ensure the proper operational process of the software. Postcondition. What kind of postcondition do we have after computing the dose? We need to replace the previous reading R0 by R1. That means we update the readings, and then R1 will be replaced by R2. Side effects, well, we don't have any for this case. Other software may have. It depends on the software that we are discussing or we are dealing with. Okay, tabular specification. I said hold your patience. I'll explain about the action here in details in a while. Now, when we use the structured way of presentation, or this for presenting the specifications of the requirements, now we may get stuck with some points like this one where we cannot exactly understand. Well, you may say, it is really tough for me to understand all these details. What am I supposed to do exactly? So in that case, we need to have, you can say, a refining process, or an alternative way that makes things easier for us to understand. So this is exactly one of the good examples about the scenario. Now look at the tabular specification. We take one tough representation of action, and then we separate it or we provide it, or we represent it in a tabular form. Now look at the condition. We have an action and condition. If sugar level is falling, how do we know it is falling? That means the current reading is less than the previous reading. Well, if it is falling, then we don't need to provide any dose. Dose is 0. That means the sugar level is fine. If the sugar level is stable, also if the current reading is equal to the previous reading, then the dose is 0, that we don't have to provide anything. If the sugar level is increasing and the rate of increase is decreasing, well, it's increasing. However, the rate of increase is less than the rate of increase, previous rate of increase. Now, how do we know? We can formulate it in a mathematical way. The current reading minus previous reading is less than the previous reading minus the reading before it. And this is how we maintain that the rate of increase is less than the previous rate of increase, or the successor rate of increase. Predecessor, okay, rate of increase. So this is how we compute the dose, in this case 0. Now imagine that the sugar level is increasing, but the rate of increase is stable or increasing, not like this, either greater than or equal. So in that way, we know that we have to compute the dose based on what? Rounding R2, the current reading, minus the previous reading over 4. And in that case, we will get the dose. If the dose is rounded to 0, then we give the minimum dose. Otherwise, we will provide whatever the amount of the dose is supposed to be provided. Rounding, you know it, we go to an integer, actually, value of a dose. It depends. So we go to the closest integer value based on the rounding process in this case to avoid any fraction. And that's it for this session. I hope you guys will benefit and enjoy. I will benefit from it and enjoy it. I will record another session for the last part of chapter 4. Until then, have a good time. Goodbye.